of our next guest from Germany. In 1999, she created Cannabrics. She has established the first company that commercializes material for alternative construction and restoration in southern Spain. Her uh, presentation is called Building Green with Hemp. Let's welcome Monika Brümmer, architect. 20 years ago, I started with hemp on this adventure when I participated in my end of career project in Berlin, and I never would have thought that one day I would, with this activity, be in a country like Costa Rica, and I've been to several other countries as well. I could never have imagined. And I also have the opportunity of collaborating in 4 continents to date on projects to start up initiatives with hemp in construction and to transfer my experience of previous years. Well, hemp is a plant that is being grown in the world. In this map I'm showing here, everything in the green areas. There's not many plants that can extend over such wide regions worldwide. Uh, Contrary to bamboo, for example, it's not so demanding of climate and it can be grown almost anywhere. The cycle of life of buildings today has greater impact than ever before. And there is a need, a global need, to reduce CO2 emissions. The industry of construction has an important contribution in global emissions of carbon. That is almost 57% of global emissions. Of those, 9% are to build materials and construction, and the rest is maintenance and refrigeration or heating of buildings. Emissions in a home, a single-family isolated home, with conventional systems like concrete blocks or bricks, is of 30 to 50 tons of CO2. And with hemp-based systems, we can build buildings that are fully neutral in their carbon print, or buildings that are even negative carbon footprint, that I'm trying to get to with Cannabric that has less than 8 tons approximately. When hemp is used to build long-lasting material that are going to be used for a long time, we foresee the reintroduction of carbon in atmosphere as CO2. It's captured or trapped in the building. In the fabrication and recycling of natural conglomerates and traditional conglomerates, they use much less energy than in the conglomerates we find today, like cement. So we are consuming more and more energy instead of reducing it. Before, there was a reintegration into nature with no waste of energy for recycling or others. And you could do much more with less. For example, in Yemen, you have buildings of up to 10 floors with just raw earth. Bioconstruction, which is what I'm dedicated to, is as old as mankind, and we are rediscovering it in these past 25 years after bad experiences of the habitat's health and inhabitants' health because of the abuse of denaturalized materials with chemical additives that started just about 150 to 200 years ago and created the syndrome of sick buildings. The diseases and ailments that a user can suffer in a modern building are caused because of bad ventilation, lack of regulation in terms of thermal materials in modern times, suspension particles and gases and vapors that are chemical and come from different varnishes and paints and some other materials for construction, among many other ailments that buildings cause. These types of the types of symptoms that can be produced are nausea, persistent colds, irritations of the respiratory airways, skin, eyes, allergies, and multiple chemical sensitiveness. There's many cases of these now. The advantages for the user of materials derived from hemp is that they create a positive influence in our quality of life. They have hydrothermal characteristics of thermal and acoustic isolation much better than conventional material, and it is possible to grow hemp without pesticides or herbicides, and this means it's great for ecological construction and for people with allergies or multiple chemical sensitivities. It protects against some types of radiation, and it is not dangerous for construction workers when applying it, different from others that are very um, ir- irritant to skin. What do we have to consider to project a habitat? First, minimizing environmental impact, trying to integrate into the landscape, integrating through local material as well, using techniques that do not require high transformation of materials that are found on site, considering how near um, water resources are available and trying to make the best use of solar energy, always preferring local resources before importing material, and minimizing the need for material and technology to have optimum comfort. Employing construction techniques that are compatible with the climate and seismic movements, and adopting forms and solutions that are compatible with the climate wherever you're going to build. Adopting construction solutions that are compatible with the materials used, for example, protecting them with a roof if it's necessary. And managing water and managing resources like water, and completing traditional wisdom with modern technologies to save energy and manage waste. Finally, using material that create healthy environments. And it's very good to use renewable materials like hemp. The hemp stock has many traits that are good for construction. It does not have albumin, which is a um, kind of food for parasites, and hemp does not have it. It's necessary. It's not necessary to use it in construction. That's a big advantage. So we have this stalk, the fiber, and on the inside, 55% fiber, 28%, and the rest is dust. Out of fiber, we can, for construction, we can use isolating material, felt for acoustic absorption, and cords or ropes that are construction material, as well as textiles and fiber that has other applications. And then for dry and wet construction, we have the smaller pieces that are very stable, and we can use bricks and blocks, and also for drywall. Then dust-based materials, which are 12% after the transformation. These are good for dry construction and for the use in biofuels. That sometimes we also need to heat the houses and buildings, and with these we can have pellets and bricks, and these can also be used to create insulation or other aspects. Building with hemp has started in France in the 90s. This is when it started in Europe. in the beginning of the 90s. So it's quite new. And there it is built with a very light system with good insulation and a combination of hemp and for walls
Load-bearing walls.
that have for load-bearing walls. And this system with very light mortars is very adequate for Northern Europe, where we have very cold temperatures and we want to have high thermal insulation. These can be compacted manually or with machines. I introduced construction with hemp in Spain 15 years ago when it was just being done in France, but I did not copy the French model because in Spain there are other conditions, not just thermal, but we do not have so much wood. So I eliminated the vertical system and I used for load-bearing walls, and I have changed the dosage and the raw materials for these mortars. One model for my material is this type of architecture in Granada, where I'm working right now, which is an adaptation to the climate that has high changes in temperature from day to night. And inside these caves, when they are restored, there's material available. It's a clay-like material that I use combined with hemp so that they both complete each other to have higher resistance and with high mechanical resistance and low thermal conductivity and high thermal inertia that we need in a warm climate. Also, both materials complement each other acoustically and they create optimum material. Instead of needing very thick walls like in a cave to cover the needs in the winter, I can reduce the size to 30 centimeters and get almost the same bioclimate comfort that a cave has. So there's a balance of temperatures throughout the year. And I get this thanks to a bioclimatic design, because good material plus good bioclimatic design complement each other to create great comfort. Here you can see some images of the Cannabric being used for the external walls and internal division walls, arcs, and always with natural mortars with clay to avoid manipulating or modifying the properties of the brick and to avoid introducing incompatible material. Here we can see a more advanced work. And since I started producing materials in 1999 in Spain, it is now being used for daily construction, and there's hundreds of Cannabric houses in Spain now, and there's architects that say they are not working with anything else because they have loved the results that this material provides in all Spain.
So we have architects, especially female architects, who are really attracted to this material. They really are appealing materials. And here, a small homage to the architects in Spain that have supported this system. There are many, and I'm really thankful for what you have done, because we have a great number of houses already built with this material. We have houses even for tourist inns and public housing and public venues, and we have bioclimatic dwellings that look normal, but they have a much higher comfort and you have to live it. And here you have cave dwellings, if you will, cave houses where we live, and hemp in addition to being used in construction block. They can be used as a lining and covering, and it is warm, resistant, flexible, so you can have continued use on the floor and it doesn't crack. You can also build vaults with that are self-supporting vaults and arches and beams and isolating material for the covering. So I can use 90 to 100 kilograms of hemp per square meter of construction. So it's a lot. And this insulation is dynamic and it's suitable for all climates and from the inside out. And because we do not have a lot of insulating material that works inside of a building, and it's very practical when you have a facade that is protected and you only are able to work in the inside. And it's very compatible with the restoration of historical buildings. For in addition to thermal regulation, it regulated through osmosis of water and thermal inertia. It is also highly permeable to water vapor. And there are three new challenges we are currently working on. First of all, developing new construction materials, for example, like prefabricated materials for faster prefab and more vertical construction with more extensive volumes. And I have been able to build up to 6-meter long panels without metallic binding, thanks to hemp, and also research vegetable mortars because this type of construction is very new. There's a lot to learn, there's a lot to research, and right now I am really thankful for the collaboration I've had with the universities of Granada and Oxford. And right now we are studying interaction of vegetables in chemical processes in the setting and the water regulation and transpiration with different aggregators or agglutinators, and also in durability in different climates and resistance to microbial attack in certain conditions of humidity, because all materials have microorganisms that can flourish under certain conditions. So I want to know how many or what types of these microbial organisms we would be dealing with and under what conditions they could bloom. We have a few works you can consult in Industry, which is called Construction and Building Materials, and plus one, which is quite recent, it's 10 days old. And these are the references that you can use. A third challenge would be development projects in countries where the crop is forbidden. In this case, it's Morocco. And we have about 100,000 tons of hemp that are either being wasted or burnt that could be used for development projects and environmental projects. A similar case is in Mexico, where a lot of hemp is thrown because only the flower is being used to produce drugs, quote unquote. In the high central rift of Morocco, hemp has been grown since the 7th century by the Sanhaja tribe legally until the independence of Morocco. They were able to do that. So since the 1960s, these people have to continue with their work in an illicit, informal manner because they do not have any economic alternatives. And they are basically a victim of drug trafficking. And we consider that given the historical and cultural context of this area, they should be given respect to their cultural patrimony. So we have done a proposal through hemp waste, and I want to send a special greetings to Abdallah in Morocco and all the politicians and intellectuals who are supporting us there to undergo or carry out this project. And if you want to get more information about building with hemp, we have the International Association of Building with Hemp, or hemp construction, which was formed in 2009. Steve Allen is his chair. They are holding or carrying out congresses every year and a half. The last one was in Granada in my installations. The next one is going to be in Germany, October 6th and 7th, 2015, which is dedicated exclusively to building with hemp. It's the only congress of or convention of this type. The second congress that we held in Granada, we did part of a film, which is called Bringing It Home, which was for the US to try to open their eyes for a new future with hemp in America. I want to finish with a small story to see the possibilities of hemp, possibilities that have been created in the last 20 to 25 years in Europe. And then we will go to the next conference. When we dream with hemp, we can wake up in a hemp mattress, take a shower with hemp soap, get dressed with hemp. We can start our day with a hemp infusion or tea, hemp tea, and eat it for breakfast. We can go on a hemp bike to a hemp job in a hemp company, mine. And when we go back to our hemp home, which was built with 15 tons of hemp, the case of this one, in a hemp, quite nice vehicle, we can rest in a hemp seat and have a hemp drink. We can read, in the meantime, a hemp book using hemp glasses. And after having hemp for dinner, we can play the hemp guitar and get warm with hemp in the stove. And Dr. Hemp can cure us, if need be, until the life cycle is closed with hemp. Thank you so much.